Right, we're going to look at comparing fractions. Now this is the skill. If we can learn this skill, if we can master this skill, then we can add, subtract fractions to our heart's content, we can put fractions in order, we can do all kinds of things. So what we've got here, we're going to learn now to compare fractions. So we have to start to think about a sequence of events now. We have to go through, in our minds, we have to go through a process by asking ourselves a few little questions and then working on those little questions as we come to them. So we've been given this question, we've got to compare those two fractions. And the question's asking us which of those two is the biggest. That's what the question's asking us. Now we can have a look at that and we can say, well, the one on the right hand side, 4/7, that looks a bit bigger because 4 is bigger than 2, 7 is bigger than 5. It might be correct, it might not be correct, it's worth a guess. But in your maths exam, the examiner's going to want to know how you chose 4 to, why did you choose 4/7 rather than 2/5? So we need to be able to compare the two fractions. So we ask ourselves the question first of all, what have we actually got? Okay, well we've got two fractions. It's not a mixed number, it's not an improper fraction, they're both fractions. Okay, if they're both fractions we can work with them both, we don't have to do any changing. The second thing we look at then is the most important number, the bottom number. And we notice that they're different. Now while they're different we can't compare them, we can't do anything with them at all. So we have to make the bottom numbers the same, okay? And we do that by a little bit of multiplication, okay? By finding a common multiple. So again, this is all going back to your times table. Now, we're in the exam. We don't happen to have this. We're not very good with our times table. So we think to ourselves, oh no, how can we find a number, a common multiple of 5 and 7. There's a couple of different ways of doing it. So this is the way I did it. I need to change that 5 and I need to change the 7. So what I'm going to do, I'm going to do my 5 times table down here. Easy to do. There's my 5 times table. I'm not going too far, I'm only going to go to 40. What I'm going to do now on the other side of my page, I'm going to do my 7 times table. And I'm looking in my 7 times table for a number that might also be in this times table. All I'm doing is adding 7 to this every time. Whoa! $35. 35 is in both times tables. So that means by just doing a little bit of multiplication, I can make those bottom numbers into 35. So I'm going to change that 5 to start with. I'm going to times it by 7. 5 times 7, 1, 2, 3, 4, 5, 6, 7. I'm going to write it down here. It's 35. I'm going to change that 7 now. I'm going to times that by 1, 2, 3, 4, 5. That's also going to give me 35. Brilliant. Now when I look at it, the bottom numbers are the same. So now I can start to do something. However, we've still got the top numbers to work on. And what we now have to think about is we now have to treat each fraction as an individual little fraction. So I'm just going to work on this one first. I'm going to come to that one in a second. And there's a little mantra, and the mantra is this, you've probably heard it before. Whatever you do to the bottom of the fraction, you have to do to the top of the fraction. I've times the bottom of that fraction by 7. I've got to times the top by 7. 2 times 7 is 14. For this fraction here on this side, I've times the bottom of the fraction by 5. I've got to times the top of the fraction by 5. 4 times 5 is 20. The question says, which is the fractions is biggest? Well, that one's bigger because it's 20 over 35 as opposed to 14 over 35. So the biggest fraction was, we quite rightly guessed, that one, 4 over 7. Does it make sense?
It does.
It makes sense.
So in the exam you will have to show this way.
Yeah, so you could do it that way. You don't particularly have to draw all this down the side. I just do that because I find that's a good way of showing people how to get the multiple. There is another way of doing that. I'll show you the other way. I'm just going to get rid of these. I'm going to get rid of those times tables. There is another way I don't particularly like using it, and I'll show you a reason why a little bit later on. It's when you might start getting big confusing numbers. There's your two fractions side by side. We're going to do what's called the butterfly method. Don't know if you've heard of it or not, but this is the butterfly method. The two fractions are side by side. We're going to draw some beautiful butterfly wings. There we go. There's the little antennas at the top. We don't particularly need to draw the antennas at the top, but there's the antennas at the top. 5 times 7, 35. I'm just going to do one line, 35 there. The blue wing, 5 times 4.
20.
The red wing, 7 times 2. (20) over 35 is bigger than 14 over 35. 20 over 35 is on this side of the butterfly, which is 4 over 7. There we go. Lot quicker.
They show you that way in GCSE.
Lot quicker.
And I prefer these as well.
They call it peanut, like monkey nut.
Yeah?
You know, like
Yeah, because
shell.
they like peanuts, aren't they? Yeah. So it's up to you which way you decide you want to do that. Sometimes you'll recognise it instantly. The numbers, you may not have to change both bottom numbers. You may only need to change one bottom number. You might not have to change both of them. For example, let's say if that was a 10. For
I was going
example.
to say, do you ever get a double number top?
Yeah, of course, yeah. If that was a 10, you wouldn't need to change that, because all you'd need to do is just do this one times by 2, which then gives you 10. So that's the thing with these, it's all about recognising, looking what you've got. Do I need to change both bottom numbers? Do I just need to change one bottom number? And that's the skill part that's coming into play now. Okay?
Like this question, you wrote now 4 by 10.
Yeah?
Without method, can we tell this fraction is bigger?
Yeah, but again, you
Or
could.
we need to prove
You'd
it?
need to prove it.
Oh.
The examiner's going to say to you, yeah, you've got that right. Shall we try a couple?
Yeah, I was gonna say, can we do pronounce it? Because of that.
So, which is bigger? Is it 3/8 or 5/12? Okay, which is the biggest? Shall we do that one together? Yeah, let's do that one together. I'll do it on here. We'll do this one together, and then you can have a go at the other two. What we're doing for the biggest, aren't we? Right, let's have a look. So what have we got? We've got 3 over 8 or 5 over 12.
So do the two bottom numbers have to be the same?
Have to be the same.
Right, okay.
Now we can't make that 8 into a 12, so we're going to have to change both bottom numbers. We recognise that. So I'm going to do my 8 times table down here. 8, 16, 24, 32. I'm going to do my 12 times table down here. 12, 24. Oh, there it is straight away. 24. 24 is in both times tables. So that means I can make those two bottom numbers into 24. So there's my 2 lines there. I've just brought them down here. 8 times 3. 1, 2, 3 gives me 24. 12 times 2 gives me 24. So now, bottom numbers are the same. So now I have to apply that little mantra, the little mantra being, whatever you do to the bottom, you've got to do to the top. So this bottom number I times by 3. So I'm going to times that top number by 3. 3 times 3 is going to give me 9. I times that bottom number by 2, so I've got to times that top number by 2. 5 times 2 is 10. Which is the biggest fraction? We always take it back to the original question. There it is, 5 over 12. Does that make sense? Yeah, does it make sense? Let's see if we're right. Ta-da, 5 over 12, because 24 is the common denominator. Alright, which is the smallest? Is it 5/6 or 11/58? Ooh.